Okay guys, let me give you just couple more examples. Let us see two of these examples. They are exactly the same function, but the limit are different. Here x tends to infinity, but here x tends to 0 plus. Okay, let us see in which problem I can use the L'Hopital's rule and in which problem I cannot. Okay, let's see the first problem. Find limit x tends to infinity x times natural log of x. The first thing you do is just plug in and then see whether it takes the one of the indeterminate form or not. When I plug in x tends to infinity, what do you get? You get limit x tends to infinity x times natural log of x is basically infinity times infinity. So if you multiply two big numbers, then that is infinity. So not indeterminate form, not indeterminate. So you cannot use the L'Hopital's rule to find out the limit. The limit is infinity there. Okay, so what is the final answer? The answer is infinity. You see that? That is the final answer. Now in this problem, if you plug in x tends to 0, what do you get? This is 0, right? This is like, if you plug in the limit directly, you will get 0 times natural log of 0 is infinity. So it is one of the indeterminate form. Yes, it is indeterminate form. Okay, but to use the L'Hopital's rule, you need fx over gx form. Okay, because what does the L'Hopital's rule say? Limit x tends to c f over g is equals to limit x tends to c f prime over g prime. That's what the L'Hopital's rule say. But we don't have f over g here. We just have fx times gx. So how do I handle this problem then? Okay, let us see that. So solution is limit x tends to 0 plus x times natural log of x. This can be written this way, right? Do you agree with that? Limit x tends to 0 plus, can you write like this, natural log of x, right, divide by 1 over x. You can write that way, right? Because when you multiply this, if you write in the product form, you can write natural log of x times x over 1, right? So this is basically 1 over x. Now if you plug in the limit, what form do you get? It is infinity over infinity form. You see that? Because 1 over 0 is infinity, there is natural log of 0 is infinity. So this is also, you can use the L'Hopital's rule. Let me write down that. So that can be written as L'Hopital's rule. I'm using that. Find the derivative of the top is 1 over x. Divide by, find the derivative of the bottom. So what is the derivative of 1 over x? Do you know that? That will be x to the negative 1 prime, right? So it will be power rule, negative 1 times x to the negative 1 minus 1. That will be negative 1 to the times x to the negative 2. So basically it is negative 1 over x square. I'm moving that. So the derivative of the bottom will be negative 1 over x square. So don't forget the limit. Limit x tends to 0 plus. Okay. Now how do I simplify this? It is basically limit x tends to 0 plus, and if you write that 1 over x times negative x square over 1, there is the fraction of fractions, correct? So I want to write in terms of the product of two fractions, 1 over x, the top fraction times the reciprocal of the bottom fraction. Now if you simplify this, you get there is x divided by x square will be, this is basically x times x, right? You cancel one of that x there. So basically you get, basically you get equals to limit x tends to 0 plus negative x. When you plug in that, you will get 0, right? So basically the limit of this is 0. That's what you get. Okay, so that's the difference. See that they are the same function, but the limit are different there, right? And then with this limit it is 0, with this limit it is infinity. Let us look at the last example of this section. So you have find the limit x tends to plus 8 over x squared minus 4 minus x over x minus 2. Again, the first thing we do is we plug in the limit directly and then see what types of indeterminate form does this function take when you plug in the limit. Or is this indeterminate form or not? If it is, then we can use the L'Hopital's rule. If it is not, then we cannot. Okay, let's plug in the limit directly. You get 8 over, although it is 2 plus, we just plug in 2, right? So you get 8 over 2 square is 4 minus 4, that is infinity minus and then 2 over 2 minus 2, that is 2 over 0 again, right? 8 over 0 is infinity, minus 2 over 0 is infinity. So this is that form. So it is indeterminate form, okay? So how do I do this problem is, so basically what we do is we try to combine these two fractions and then simplify and then take the limit. If you get indeterminate form again, you will just basically you will get 0 over 0 or infinity over infinity, and we use the L'Hopital's rule, okay? Let's do that. So equals to limit x tends to 2 plus, I want to combine those two fractions, okay? Because this is basically x plus 2 times x minus 2, right? Let me write down that 8 over x plus 2 times x minus 2, right? And then minus x over x minus 2. You see that? So how do I simplify this? Is there anything common between these, the first term and the second term? Yes, there is, right? The x minus 2 is common. Let me take 1 over x minus 2 out, and then what is left is 8 over x plus 2 minus just x, because 1 over x minus 2 is pulled out already, right? So limit x tends to 2 plus 1 over x minus 2, right? I want to combine these two. So there is 1 on the bottom. So just multiply x plus 2 times 1 is x plus 2, and then do the cross multiplication, right? You multiply this with that one. So what do you get? You basically get 8 minus x times x is x squared, and then minus, oh, you can write like this, x times x is x squared, and then plus x times 2 is 2x. You can do that way. So basically limit x tends to 2 plus, right, 1 over x minus 2. If you simplify that, what do you get? You get 8 minus x squared minus 2x, right, divided by x plus 2. Now you can combine those two, okay? Let me combine that. I'm not putting the limit in. I want to just write the simplified form first. So limit x tends to 2 plus, right? So because the x, I want to write the x squared positive, okay? So I want to write the negative 1 outside. So negative 1 times x squared plus 2x minus 8 divided by x minus 2 times x plus 2. Let me simplify that. So that is limit x tends to 2 plus and then negative 1 x plus 4 and then x minus 2. Those are the factors of the top, right? And then you get x minus 2, x plus 2. You see that the same common factor on the top and bottom. So you divide, that will become 1, right? So that will be, what is left is limit x tends to 2 plus negative x plus 4 over x plus 2. Let's plug in the limit. What do you get? If you plug in the limit there, you will get basically negative 2 plus 4 divided by 2 plus 2. Although it is 2 plus, we just write 2, right? So negative 6 over 4. So the final answer is negative 3/2. So the final answer is negative 3/2. So basically, we didn't have to do the L'Hopital's rule there, did we? So you notice that we didn't use the L'Hopital's rule anywhere, although it was the indeterminate form, okay? I mean, problems can be done with or with, some problems can be done with or without using L'Hopital's rule. So here, if I want to use L'Hopital's rule, I would use right here, like this, okay? So what do I get? Limit x tends to 2 plus, right? And on the top, I got 8 minus x squared minus 2x, right? When you simplify that, divide by, on the bottom it is x minus 2 times x plus 2 is x squared minus 4. So if you take the limit, what form do you get here? You get 8 minus 2 squared is 4 minus 2 times 2 is 4. 8 minus 8. 8 minus 4 is 4 minus 4 is 0, right? You will get 0 over, if you plug in that here, you will get 0 over 0. So you can use the L'Hopital's rule here, right? So if you do that, you will basically get, equals to limit x tends to 2 plus, let me write L'Hopital's rule there. So 0 minus 2x minus 2 divided by 2x, just 2x, right? Because the derivative of x squared is minus 8 is 0, derivative of 8 is 0, derivative of negative x square is negative 2x, minus derivative of 2x is negative 2, divided by derivative of x square is 2x, and then minus 0, right? Minus 0. If you plug the limit, what do you get? So basically you will get a limit x tends to 2 plus negative 2x minus 2 over 2x. If you plug in the limit, you will get negative 2 times 2 is negative 4 minus 2 is negative 6 over positive 4. That is negative 3/2. So basically, instead of doing all these other steps, you could do the L'Hopital's rule after you get the fx over gx form, right? After you get the f over g form, because here you had minus in the middle. There are two different terms. But after you get a single term or f over g form, a rational function, then you will be able to get the L'Hopital's rule if it takes the indeterminate form. Okay guys, thank you very much. That's the end of the videos for this section.